Combinatorial technology is a term most people are not familiar with. So one of my missions here is to not just introduce it, but also to integrate it into the discussion of human evolution with respect to climate change, but also to the development of structures. Combinatorial tools, I'll explain what they are part of all the structures we work in today. Everything in this room, what I'm wearing, where you're sitting, our tools, our phones, are made through the concept of combinatorial technology. I hope that's intriguing. So buckle up, 7 million years to cover in what's left of the 18 minutes, with some climate change thrown in, because it's highly relevant what's happened the last 6 million years for what's coming in the next few decades. I'm going to look for the earliest evidence for structures in the archaeological record, and I feel privileged to offer to you what is currently the earliest evidence. And then I will introduce this term combinatorial technology. And just put simply, it's combining tools with handles. Let's make it even simpler, putting stones on sticks. But I'm going to make it, I hope, a bit more interesting than that. This busy diagram shows 7 million years of time, and it shows the 20 or more fossil species which we attribute to a group called hominins. All of us in here are hominins. What does that mean? It means we habitually walk on 2 legs. We are bipedal. Our daily lives, we move about in the world on 2 legs. Darwin recognized the importance of this for freeing the hands for making things, for carrying things. I think we could add to this the freeing of hands for gestures, for communicating. So all of these species are hominins. And the genetic and fossil evidence points that we split from the last great apes about 7 million years ago. And I've distinguished in here early hominins. These live in woodland environments. And I'm just going to introduce one more definition. Humans. You may think you know what a human is, but there are different ways of using this term. And paleoanthropologists often think of humans in a very broad perspective, not Homo sapiens, but members of the genus Homo. So I've highlighted this genus, of which there are 10 or more species of Homo, and it's within this genus, our genus, we find the first evidence of structures. Now, climate change. The diagram behind me shows in the blue wavy line, it almost looks like an electrocardiogram, a sort of heartbeat through time, and that's a way I think about it. You will see that the blue diagram is shifting. There's a gradual change over time, and this is in temperature. So we're looking at 6 million years here, and the first 3 million years is quite stable. The temperature is quite warm. It's even warmer than it is now. This is the world of the early hominins in the woodlands of Africa. 3 million years ago, there's a change. A gradual one, a marked change to cooler conditions. Maybe it correlates with what we see there, the first stone tools. It's the beginning of the archaeological record. Then that trend increases, getting cooler and cooler. And as you look towards the middle of the diagram, you'll see the next black bar. That is the first formal tool in the archaeological record, the first shaped object in the archaeological record. This represents, to me, the beginning of what I would call a cumulative cultural tradition of learning from others. And we've seen that with the birds, learning from others and passing that information on to the next generation. And that's an interesting question. How is that done? And I think our next speaker is going to deal with this. Michael, certainly it's yours. And so that's 1.7 million years ago. And then look at what's happening to not just the heartbeat of climate change, but the amplitude. So the difference between the peaks, in this case, peaks of warm at the top and peaks of cold. These are ice ages. All of these are ice ages, so remove from your mind the idea of one ice age. There are hundreds. And then about here, just about 800,000 years ago, lots of numbers, I know. The heartbeat gets into a condition which, if it was me as a human, I would call this a medical emergency. I'd get myself to a hospital. Paramedics, please help me. The amplitude is not only getting extremer, it's getting colder, but the time range of these climate cycles is getting longer. 100,000 years for a glacial cycle. We're here, it's 41,000 years. These cycles rewrite habitats. They stress us as humans in these habitats. And for these 800,000 years, I'm going to say this is a long-term climate change emergency. And I'll just use that term again. What do we see happening in this emergency? The first evidence of structures, and later on, we emerge about 300,000 years ago. Now, before I go, I'm going to the next slide, but before I move on, we've heard about GPT. I want to introduce you to the first, GPT. It's the first general purpose technology, and that's striking sharp flakes of stone from blocks of stone which have certain properties which are understood by the hominins who made them. What do these stones do? They open up the environment for us. They allow us to extract animals, kill them, butcher them, allow us to process plant foods. And the evidence from this particular site 3 million years ago is really interesting to me because there are traces of woodworking. Now, wood is going to feature in this story. But just already from the beginning of the archaeological record, we have hominins who've replaced the loss of claws, bodily strength, with technology. Okay, that enables early hominins to move out of Africa soon after 3 million years ago. We don't know who they were, but we find their tools from Jordan to China. Now, I'm just going to choose one species here, Homo erectus, a long-lived human. First appears 1.9 million years ago in Africa, East Africa, and becomes extinct about 110,000 years ago in Southeast Asia. So it's widespread geographically. Homo erectus has my body shape, has your body shape. It's a terrestrial species. It doesn't have the facility for climbing the trees like earlier hominins did. It didn't nest in trees, we think. And this species is important not just for its spread, but we also have that archaeological record that I was told you about, which I think is the kind of early evidence for cumulative learning. These are complex tools. These are called, they are large cutting tools. They are called hand axes as an offhand name, but they're symmetrical in plan view, symmetrical in side view, and symmetrical in cross section. They're not easy to make. They are learned through observation, perhaps, yes, but you need to learn from an expert. That's important. And we know from the study of these tools, they too were used for woodworking. Last stop for Homo erectus is the basal human, from which other species evolved during this time of what I call the long-term global climate crisis. 800,000 years, then we've got this heartbeat, which is in spasm. And I'm going to give you a case study of how rapid climate change can be, how it affects people's adaptation. There's a concept here, a hypothesis called variability selection. It was put together by Rick Potts from the Smithsonian Institution in the 90s. And the idea here is that humans didn't evolve to a single environment, the East African savanna. No, it's about the evolution of flexibility, versatility in the face of variability. And the variability here is climate change. As archaeologists, we can pick up some of this variability. We can see some new things that are created or used or curated. Fire becomes a focal point in settlements, not just for cooking. We could also say perhaps fire is also a way of extending the daylight and time for communication. We have this combinatorial technology. We have shelter. We also see some biological changes, an extended childhood. And what happens with extended childhood? That's more time to learn. But who are you learning from, and how is that learning taking place? So I've used this term cumulative learning as a very cultural element of us. Do we see it with birds? Perhaps Sue would say yes, yeah. And just as an aside, we see within this climate change crisis, the development of the modern human brain size in relation to body size. And then we see that by 500,000 years ago. Then we just think about when did language evolve and how did it evolve? I'll leave Michael to take us through that. Okay, look at these three words, the Green Sahara. Does that seem strange? It's meant to challenge you. It challenges your preconception. What is he talking about? Well, he's talking about this. That's what we think of the Sahara. Sand, rock, no water. It's a difficult place to live. That's how it is today. Have a look 10,000 years ago. It's a land of lakes, rivers, deltas, full of animals, full of people. I'm not saying this really meaning this. It's the Garden of Eden. Life was easy. And the people there are hunters and gatherers and fishers. They start making pots. They've settled down. That lasted 4,000 years. Then it ended. That is the climate stress in a microcosm. Okay, I'm going to introduce a small period of stability. Having said about all this stress, This is 500,000 years ago in the southern end of the Rift Valley of East Africa, this place called Kalambo Falls, which is where I worked. But behind these beautiful falls lie sediments that have remained waterlogged for 500,000 years. We excavated these in 2019. The students here are working on 2 waterlogged pieces of wood. They're actually trees that have been shaped to work together. This is not a natural formation. They lock together, and I'm going to talk more about this. This site is roughly 500,000 years old. We never expected to find this, and that's why this has been such a remarkable find. The world is coming and saying, what? What are people that are not us, Homo sapiens, doing making substantial structures? Well, let me just show you some of the evidence in the last 6 weeks. So this is new, so don't tell anybody about this. But you will see this is the top of the structure. This is a mapping using a variety of photographic techniques of the human intentional manipulation of the wood, color-coded for directions, so green, which is more vertical, and then long purple strikes here. They're working with the grain of the wood. That's the top. They are flattening it. You may just see there's a little bit of rounding here. This is a notch. Flip the wood over, and you see intensive working on the inside here. These people, whoever they were, knew what they were doing, what they wanted. It's intentional. It's active changing of that material. What does the notch do? On the right here, on my right, this is a Scandinavian notch, making log cabins. People make notches because it holds the logs together. On your left, that's the notch from Kalambo Falls, and what does the notch do? Well, when I first saw this in the ground, my first thought was Lincoln logs. Anybody grow up with Lincoln logs? Hands, please. Yeah, I'm not going to look at the age range. Yeah, okay, here, look, I just carry these around. I don't know why, but yeah, hey, here's a Lincoln log, here's a notch underneath, and here's a Lincoln log. And it fits on the top, and the notch locks this one from side-to-side movement, and the notch locks this from back-to-forward movement. What we're seeing in Kalambo Falls is one locking the side-to-side. But they solved the problem of the back and forth another way, and I call this folk engineering. It's a deliberate and intentional understanding of materials and changing the way it works. Now, here is the notch, and the log under here has been shaped so it drops. It means that this top log, as it moves down, it will hit the underlying log and can't move any further. These clever people shaped the underlying log at its end, which you can't see it, but the marks here show that the end has been flattened and is broader than the width of the notch on the top. They've locked it in. They've created a stable framework to hold something. We don't know what's on top. Platform for a hut, platform for storage, or a walkway. That's the great mystery that still remains from Kalambo Falls. But the point is, they are raising whatever activity is above a damp environment. They've understood the environment. They are manipulating. I call this the earliest evidence of the built environment. Maybe I'm exaggerating. That wouldn't be news to many people. This is not the only find of its kind from Kalambo Falls. In the 1950s, archaeologist Desmond Clark, who was based in Berkeley, he found 3 other of these large trees that were cut, the ends shaped and with a notch in the middle, but he didn't have the evidence that they were actually formally worked. And when you look at his excavations, I see this, and I see these big tree trunks and forming sort of a rectangle underneath, and you can see there's one of these notches in the middle, and I almost salivate with the prospect, here is a hut foundation. But again, I didn't say that. Right, how was this made? This is one of the large cutting tools of this period. It's called a cleaver, and I'm holding it in my hand. It's beautifully designed. It has a very fine, strong, and long, broad cutting edge. And this piece from Kalambo Falls maps onto the marks in this artifact from Kalambo Falls. They're exactly the same dimension. They were using cleavers to cut the trees down and to do the initial shaping. They knew what they were doing. We tried to replicate those cleavers and use them. Let me just go back. We tried to use them handheld to work small pieces of wood that were green, and we just could not generate the leverage to cut what would have been a tree of this size, hardwood, in the Zambian forest 500,000 years ago. This is where combinatorial comes to the rescue. It's a new concept of making tools. It's additive. You combine things together to work together in a way that's never been seen before. Before, everything's designed to be held in the hand and used directly in the hands. This additive approach, a modular technology, increases the length of the arm, increases the power you can put into the working edge, increases the efficiency of the human body. I'm going to show you a test of the efficiency hypothesis, but also just want to, in passing, say, this is the foundation of the first machine. What's the first machine? Well, I've given you the answer here. It's the bow and arrow. There is stored energy in the bow and in the string, and you add the human, and you've got a beautiful working thing. In the African record, they appear about 70,000 years ago. Okay, here's a published experiment. I thought Sue's got experiments, so I'm going to put one in, but I'm not. I'll be very brief because I know my time is running out. This is a test of the efficiency hypothesis. We had 40 students, male and female. They're rugby players, so they're physically fit because it's going to be a tough task. So we've got hafted tools and non-hafted. They're using them on and in a short way. The hafted tools we could show after we recorded their muscle movement, their physiology in terms of oxygen consumption, heart rate, that the hafted tools were more efficient. The efficiency has an advantage here, not just in terms of producing more food, but it may have an evolutionary advantage in terms of the individual fitness, in terms of passing, able to generate offspring and their offspring, able to generate offspring and survive through this greater efficiency of the technology. That may be pushing it a bit too far. Pushing it even further, it may even contribute ultimately to population growth in some areas. Let's see this in action. So this is the get-up in the lab. So the combination of physiological and kinematic recording, and this is going to be loud. This is a hafted hatchet with a set piece of wood. We're recording the bodily movements in this form here. So we've got the X, Y, and Z coordinates. Wow. Okay. And we did that with handheld, and I can tell you it's painful. But we were able to demonstrate it quantitatively that hafting is an element of efficiency. Who were the makers? Possibly. Homo heidelbergensis is a species that is part of this time period, 700,000 to 300,000 years ago. This is possible maker. The next oldest object, and I can see I've got a minute left, so this is going to be very quick, is a deep cave structure made by Neanderthals 176,000 years ago. This is extremely unusual. They went down into the cave, took torches, lit fires, broke pieces of the cave formation, stalagmites, and built semicircular walls with a cross piece to give stability. We have no idea what was going on. Let's call it ritual in advance of Göbekli Tepe. Okay. The makers were Neanderthals, very similar to us. They lived in northern climates. They had a broad range of diets. They made lentil cakes. They made wooden spears 300,000 years ago. They decorated their bodies, decorated their caves, decorated with paintings and engravings. They were different from us, though. They lived in small populations, which means in terms of cultural learning from others, they have a smaller pool of sources of information. Maybe that's the reason they're no longer with us. But many of us have their genes in our bodies. I'm 1.1% Neanderthal. We can talk about that. Yeah. And then finally, I know my time's up, but you need to see this because very few people have seen this. We're back to Homo sapiens, or we are now with Homo sapiens, the last 300,000 years. And from my understanding of the African record, this is the earliest evidence I can find of a structure. And it happened to be one I excavated back in the 90s. And it's a windbreak inside a cave. Why would you do that? You can ask me about that. But it's a temporary structure, unlike what we saw at Kalambo Falls. This is very distinctive and very typical of Homo sapiens of the last 300,000 years, adapted to mobility through the technology to cope with the climate emergency. Now, one more image here from the one fabulous Kenneth and Kenneth brothers. Yay. They've humanized the hominin record for us as archaeologists, and also I hope for you as the public. That's the face of the earliest member of us, Homo sapiens, from 300,000 years ago, from the site of Jebel el-Hud in Morocco. And that leads me to the summary here. We have been shaped culturally, biologically, technologically. Technology is part of culture, so I just make that, as part of this climate emergency. Structures are a response to limitations, but also opportunities in the environment. And as I began saying, everything we make is based on combinatorial concept, I'll end on that too, because we take that concept forward as we try to cope with our current climate emergency. So I have to thank the funders, the British taxpayer in particular, through the Arts and Humanities Research Council. You didn't have to do this, but all sorts of people were involved in the project in Zambia. So thank you for your time.